In games like Elden Ring, difficulty often comes from learning patterns. Enemies repeat attack sequences, and as players, we adapt. Once you recognize the timing and direction of an attack, the game becomes less about reaction and more about memorization. Predictability, even in difficult games, eventually becomes a weakness. But what if enemy behavior couldn't be memorized? What if patterns didn't truly exist, not because they are complex, but because they are fundamentally unpredictable? If we look at Elden Ring, the enemies react to players based on their positioning. So in order to remove this, I explored quantum randomness applications in video games. To experiment with this idea, I built a physical whack-a-mole game powered by quantum computing. The game runs on an Arduino with an OLED display and a joystick input. Instead of using traditional pseudo-random logic, mole positions are generated using a quantum circuit simulated through Qiskit. The reason why you see no moles on the screen as of right now is because the quantum circuit isn't currently running, so it wouldn't be sending any data to the Arduino. Each mole spawn is determined by measuring qubits placed into superposition, being the outcome cannot be predicted ahead of time. Now it's time to run our program. Now that the program is running, we can actually see these moles popping up. Now these moles aren't just based on a pseudo-random algorithm, it is actually based on quantum data sent through a Qiskit circuit. As you can see here, in real time, moles are being generated on the Qiskit circuit, and then it is sent to the Arduino. Now score also updates, as you can see here. You can see the score updates, and what that score does is increases the speed so the game gets harder over time. This snippet of code is the heart of the entire program, specifically the Qiskit end. This function creates a small quantum circuit with 3 qubits and puts each qubit into a superposition using Hadamard gates. When the qubits are measured, the result is a truly random 3-bit number generated by quantum uncertainty, not a predictable algorithm. This randomness is essential because it removes patterns that players can learn, making the game's behavior unpredictable and more engaging. One challenge I ran into while making this project was getting the Python script and the Arduino to communicate effectively. Sometimes the synchronization failed, sometimes data jittered, and sometimes data didn't even send at all. So in order to fix this, I went through some debugging, such as resetting the serial connection, making sure both sides are synchronized, and a lot more. Now this isn't just a fun little project to make Whack-A-Mole harder, it's an actual simulator to show where we can remove predictability where predictability becomes a weakness, such as cybersecurity, simulations, and decision-making systems. Through this project, I learned how hardware, software, and quantum concepts can work together in a unified system. If I continued something like this, maybe I would make some more complex game advancements, such as making quantum data and making it adapt to player movements. Thank you guys for watching. Please be sure to check out the article I made on this project. It goes more in depth on the hardware and software and how to set it up yourself.